Hi everyone, my name is Chalana and I'll be discussing the IEEE 802.11 wireless networking standard, wireless LAN standard. Here I will discuss the IEEE standard and then how channels and frequencies are used for wireless LAN communication, followed by a brief introduction into the three types of frames used in wireless LAN, after which I will discuss the association process and finish off with a demonstration using Wireshark. 802.11 is the standard for wireless LAN communications developed by the IEEE. The original 802.11 standard was put forward in 1997 and the protocol has undergone many different revisions to reach where it is today. 802.11 operates on the physical and data link layers of the OSI module using radio waves and frames. Wireless LAN communications is based on carrier sense multiple access over collision avoidance or collision detection that is used in the internet. The way how this works is once a frame is assembled, if there is a free channel available, then transmitting device will send a ready to send frame, and if the transmitting device receives the clear to send response, then it will transmit the frame. In case there is no free channel available or transmitting station does not receive a clear to send response, then it will hold off for a random back off time before transmitting again. From 802.11 to 802.11be, the wireless LAN protocol has undergone many different revisions. Wireless LAN operates on 2.4 GHz and 5 GHz radio frequencies for transmission over equally bandwidth divided channels. These divisions help avoid collisions in transmissions. 802.11 has three types of frames associated with it: management frames, control frames, and data frames. Management frames perform supervisory functions. They are used to join and leave wireless networks and move associations from access point to access point. Control frames are used in conjunction with data frames to perform area clearing operations, channel acquisition and carrier sensing maintenance functions, and positive acknowledgement of data. Control and data frames work in conjunction to deliver data reliably from station to station. The data frames carry data from station to station. For a station to communicate with an access point, it has to be authenticated and associated with the access point. During authentication, the station connects to the access point, after which association occurs where access point and station share their capabilities to see if they are compatible for communication. If compatible, then association becomes successful and communication will occur. Deauthentication is where the station disconnects from the access point, stopping all future communications. Now I will demonstrate how to capture packets using Wireshark. Before capturing packets, first we have to put the NIC into monitor mode from managed mode. The reason we are doing this is while it's in managed mode, the NIC is in managed mode, it will drop all the packets that is not addressed to it, and therefore not all packets will make it through to Wireshark. A problem that we may run into at this point is the NIC might not support operating in monitor mode. Changing of mode is also dependent on the drivers of the wireless network card and also depending on the OS. To change into monitor mode, first I will open a terminal window like this, and using the iwconfig command I can check which mode it is currently in. Currently it is in managed mode, and to change the mode, simply we will do this command VLAN 0, and if we run into this particular error, what we have to do is first bring the wireless interface down using this command, and then using the iwconfig run this command, and then bring it back up, bring the wireless LAN back up, and using iwconfig you can see that now it is in monitor mode. And now to start capturing packets, we can simply type sudo Wireshark, and then using this VLAN 0 interface we can start capturing packets. Now I will go through the packets that was captured using Wireshark. First thing that we can notice here is a lot of beacon frames has been captured. Beacon frames are frames that is broadcasted by the access point announcing its existence. By expanding this beacon frame information, we can get an idea of a lot of information with regards to this access point. Under the radio information tag, you can notice the protocol revision it's using, the data rate, which is 1 megabit per second, the channel it's broadcasting this beacon frame on, the frequency that it's using, and signal strength and noise levels about the broadcast. Under the beacon frame tag, we can see the receivers, which is a broadcast message, therefore it's transmitting to the broadcast address, and the transmit address, which is the MAC address of the access point, and other information. Under the wireless LAN tag, we can see the beacon frame broadcast interval or the frequency, which is set to 100 milliseconds, which is actually the default value for beacon transmission. Then the SSID or the name of the access point, and the rates that it supports. This access point supports 4 data transfer rates, which is indicated here. The B here indicates that whoever is connecting to this access point should support these rates. These rates are mandatory. And in addition to that, we can see the extended data support rates, extended supported data rates. So if you notice over here, not all of the extended rates have the B, which means not all of them are mandatory. At the beginning of the trace, the host was already connected to or associated with the access point. So next I will go through the data transfer frames in this Wireshark trace. First I'm going to apply a TCP filter like this to isolate all the TCP traffic in this trace. Let's analyze this first packet, which is a sync TCP. From the TCP header, we can see that this is a web request because it's communicating on port 80. Opening the IPv4 header, we see the source where the packet originated from. This is the IP of the host PC. Destination is the destination IP address of the web server where it's requesting this HTTP request from. Opening this IEEE 802.11 QoS data header, we can see the receiver address, transmitter address, destination address, and the source address. and the subtype of this whole packet. What's different here over a wired LAN TCP packet is these 4 headers. A wired LAN TCP packet would have different headers. As you can see here, this is another trace that was captured, and if I use this tcp.port == 80, I can find a request that is the same as the previous one we analyzed. Over here we can see there is an Ethernet 2 header along with the IP version 4 and the TCP header, whereas in the wireless LAN packet we see these 4 headers, which is applicable to wireless LAN. Now we will look at the association and dissociation process in wireless LAN. To analyze the association process, I will go through 4 types of frames: authentication frames, association request frames, association response frames, and deauthentication frames. To find out the authentication frames, I will use this filter in Wireshark. It will bring us these packets. These are the authentication packets, and if I expand the authentication packet over here, you can see the type of the frame is a management frame, and under the VLAN tag you can see a couple of fixed parameters. Is the authentication algorithm that's being used is open system, and gives the status code as successful. That means it was successfully authenticated. Next we will analyze a request frame, association request frame, using this filter. Again, as you can see here, I will check the association request for this 30 Monroe Street SSID. Again, this is a management type frame, and here we can see type parameters passing the SSID and the supported rates, the QoS capability, and extended support rates to the access point. Then we will look at the association response frames using this filter. Here we can see association response frame. It shows whether the association was successful or not. Again, this is a management type frame. Under this tag we can see that the association was successful, and the reply shows which of the data rates that it's communicating with, and also the supported extended data rates. And then finally I will go through the deauthentication frame using this filter. First I will filter it using this filter, and we have a couple of deauthentication frames. The deauthentication frame is again a type of management frame, and the significant thing to check here is this reason code. It says unspecified reason. It just means that the deauthentication was successful. I hope that by now you have got a better understanding of the 802.11 wireless LAN communication and packet analysis with Wireshark, and is capable of attending this on your own. That's the end of this demonstration. Thank you.